putting 1, right?
Yep. Okay, so today we're going to be discussing inverse functions. Now, notice I've got a relation here. Now, a relation can be a function or it cannot be a function. It just depends. A relation is just a relationship between numbers or a relationship between x and y values. This is relation A. Relation A has the set of ordered pairs. Now, this is set notation. When you use a brace, like you see here, this brace is what we use to denote a set. A set is a group of things. Could be anything. Could be ordered pairs, could be just numbers, could be letters, could be people, could be colors, could be any set of anything. Just a group of things. All right, now, notice that these three ordered pairs do not have any repeating x values. What does that tell you about this relation? If the x values do not repeat, then it is called a function, yes. All right. So this is actually a function. Now, when we talk about inverse of relations or functions, it does either one. What we're doing is we're simply swapping the x and the y values. So if you look at the inverse of A, we use this notation, -1, to show inverse. This -1 is not an exponent. It has nothing to do with the laws of exponents. It is a notation device. Thank you. Something we use to show that we're dealing with the inverse. So the inverse of relation A is 4, 2, -3, 8, and 11, 6. Now, is this inverse relation a function? Why? Yes, you're right. Why is it?
Because it doesn't have repeating x values.
Exactly, because it doesn't have repeating x values. So, what type of function was this original function? This original function is called a one-to-one function. So I'm going to say, so A is actually a one-to-one function because neither x or y values repeat. So for a one-to-one function, the inverse will always be a function. So you'll end up with two functions when you do the inverse. That will always be the case. We'll see an example where the inverse will not be a function. We'll see one like that later on. So A is actually a one-to-one function because neither x or y values repeat. That's probably not the best grammar in the world, but it is what it is. Okay, let's take a look at the next slide. All right. Okay, so if you remember from the last slide, the previous slide, we said that a to the -1 represented the inverse of relation A. Well, when it comes to functions, we're going to say that f to the -1 of x is the notation for inverse functions. But when it comes to working with and determining whether or not or finding the inverse of a function, what we're going to use is y instead of f of x. And you should know that f of x is equal to y. So we will use y instead of f of x when working with inverse functions. So let's say we are given the function y equals 2x plus 3. If this had said f of x equals 2x plus 3, we would use y instead of f of x. Now, to find the inverse, we're basically going to follow 3 steps. Sometimes people include a 4th step. Sometimes you just think of it as 2 steps. I'm just going to think of it as 3 steps, and this is why. Number 1, Once you have y instead of f of x, just swap the x and the y. Step 2, solve for that y value. Step 3, change the y that you just ended up with to f inverse of x, because we don't want there to be confusion at the end. Because if I end up with y equals this, and I started with y equals this, somebody that's not trained, doesn't understand, they'll think you're talking about the same thing, but it's different. Because y at the end is actually the inverse. All right, so here's an example. Step 1, we swapped x and y. So that gave us x equals 2y plus 3. Then you simply solve for y. Subtract 3 from both sides. So that gives you x minus 3 over 2 equals 2y over 2. Cancel your 2's there on the right. So y equals x minus 3 over 2. Or f negative 1 of x equals x minus 3 over 2. All right, let's take a look at some other examples. All right, so find the inverse of each of these. So the first one, y equals 11. There is no x for us to swap. But we're just going to swap it. Where there's a y, what do? We put an x. There's your inverse. Ta-da! Now, I said no inverse earlier, and I should have not said it that way. It has an inverse. It's just not a function. X equals 11 is not a function. Can you tell me why x equals 11 is not a function? If you graph it, what does it look like? What is it? It's a vertical line. A vertical line has repeated x values. You're using the same x value every single time. Therefore, x equals 11 is not a function. All right? But it didn't ask us to tell if it was a function or not. It just says, find the inverse. X minus 11 is the inverse. Okay? All right, now, I suppose you could say f inverse of x, f negative 1 of x equals 11, but I'm just going to leave it like this right now. All right, number 2, y equals 3x. So first step is what? Change. Swap them. So x equals 3y. And then solve for y. So what's the first and only step to solve for y? Divide by 3. So y equals x over 3. Or you could say 1/3 x. Now, again, be careful because we really need to understand, and we want people to understand, that it's the inverse. The inverse is equal to x over 3. All right, number 3. Okay, again, swap x and y. Yes. So x equals y minus 5 squared. If you remember back to Algebra 1 or Coach Rankin's class or Algebra 2, how do we undo something that's been squared? Square root it. So we're going to take the square root of both sides. That's going to give me, on the right side, y minus 5.
Oh, yeah.
Remember when we had to complete the square? Solve a quadratic equation by completing the square? We had to do this. All right, and then square root of x on the left. I don't have a lot of space right here, so I'm not going to show it. I'm just going to say it. You have to add 5 to both sides, right? So you might have more space than me. So the final answer here is y equals root x plus 5. But make sure you don't put that 5 underneath the root symbol because it's not underneath there. The final answer is f negative 1 of x equals root x plus 5. Okay? So you need to change that last y value to the correct notation.
So we have to put it in that.
All right, let's take a look at number 4. Again, swap your x and y. So we'll have x equals y squared minus 36. What's the next step? Add 36. So that gives you x plus 36 equals y squared. But we don't want y squared, we want y. So how do I undo that? Square root it. So my final answer is going to be y equals root of x plus 36. And you can't take the square root of 36 right here, guys. This is not just 36. This is x plus 36. It's like, you know, a peanut butter and jelly sandwich was made of peanut butter on one side, jelly on the other. But when you put it together, it's now a PB&J. Right? It's not peanut butter and jelly. It's peanut butter and jelly. Right. This is one thing. You can't take the square root of x plus 36. It's done. That's simple. All right, so make sure you write it in the correct notation. And that's your answer. Okay, there's your inverse. Now, this is a square root function. If you look over here at our wall of functions, you can see what a square root function looks like, the basic parent square root function. It looks like half of a parabola. All right? Okay, let's look at number 5. Number 5 is going to be very similar to number 4. You're going to swap x and y. Subtract 2 from each side. Oops. X minus 2 equals y squared. Square root of both sides. So that y equals root x minus 2, all underneath the square root symbol. And you can say f negative 1 of x equals root x minus 2. Okay, here's your final answer. All right, last one, number 6. Okay, again, we're going to swap x and y. Be careful when you're doing it. So x equals 2y plus 3 over 4. Okay, we want to get rid of that denominator. So how do we get rid of a denominator? How do we undo division? Multiply both sides by 4. Now, if I multiply the right side by 4, what happens is the denominator and the 4 that's being multiplied cancel out. And on the left side, I also multiply by 4. And that gives me 4x equals 2y plus 3. Okay, this is a basic algebra problem. Solve for y. So what's the next step in solving for y?
Minus 3.
Yep. From both sides. Okay, that's going to give you, I'm going to put it over here. That's going to give you 4x minus 3 equals 2y. Last step. Divide both sides by 2. So my final answer is y equals 4x minus 3 over 2, or in the correct notation, f inverse of x equals 4x minus 3 over 2.
Do you have to put it in the correct notation?
Yes. Sorry. Okay, so when we're using composition to test inverse functions, all right, let's go back real quick before we get into the composition. Just remember how to test a function. We just saw a video over it, but if I have function f, and these are the coordinates, these are the points in function f, and I want to find the inverse, I'm just going to swap the x and y values, and so I get these new sets of coordinates. But notice that I now, in my inverse, I've got repeating 8s where the x values are, which means this inverse is not a function. So we just did just an observation test, and we determined that the inverse was not a function. Well, we can use composition of functions to determine whether or not two functions are inverses of one another. Not necessarily whether they are functions or not. We know they're functions. But we can test to see if they are inverse functions of one another. So here we have an example. It says determine whether each pair of functions are inverse functions. Should be it should be pretty clear to you that when we plug function g into function f, the 7 and negative 7 cancel and you get x. When I plug function f into function g, again 7 and negative 7 cancel and it leaves me with x. So in both cases I was left with x, which is our input variable. Sometimes we call it the argument, like they did in the video I watched earlier. But yes, these are inverses. Got it?
Yeah.
All right, so in this example, f of x equals 4x minus 1, g of x equals 1/4 x plus 1/4. When we find the composition of f of g of x, we're going to plug function g into function f. When we do that, notice that the 4's cancel, because if I distribute the 4 onto each of these terms, the 4's are going to cancel out. So that leaves me with x plus 1 minus 1, and that's x. So far so good, because we wanted it to be x. Now I'm going to do g of f of x. In this case, I'm going to plug in 4x minus 1, which is function f, into function g. Distribute the 1/4 and you get x minus 1/4 plus 1/4. The 1/4 and negative 1/4 cancel, leaving you with x. So the answer is yes. They are functions. They are inverse functions. All right, so in this example, when we do f of g of x and I plug in g into f, notice that when I simplify this, I end up with a negative x. If I end up with negative x in the first try, done. It's a no. It's not. These are not inverses. Because both of the compositions have to end up as an x. So if it doesn't end up as x, then you know you can stop right there and say that they are not they are not inverses. All right, these are your homework problems. There are not many problems here. You're going to go to page 532. 22 and 32 are your tickets out the door. So when you finish with those, show me those, and then finish the other problems.